Module 8, Homework 1. We are doing rational expressions. This is probably Module 8, probably the hardest module. So we really want to take your time and follow the steps as you go through each of the problems. So we're just going to start with finding the domain of these problems so that we can cross out incorrect answers. So we need to know the definition that a 0 in the denominator is undefined. We cannot divide anything by 0 because we get an error. So we have this little graphic here, so you have NO, 0 in the denominator, is a no-no, and then OK is OK. So 0 in the numerator is OK, 0 in the denominator is a no. So if I look at this example, I have x squared minus x minus 2 divided by x plus 3. Will the value of the denominator ever be 0? Well, if x is negative 3, then I would have negative 3 plus 3, which would give me 0. In which case, that would be a no-no. I cannot divide by 0. So you're going to say that negative 3 is a restricted value of x. So another way of writing that, if you look all the way down here, is like this. This is an equal sign with a line through it. That means x cannot equal negative 3, is what that is. So the domain then would be anything that x can be, which means the domain is all real numbers except negative 3. Okay, so x can be anything except what would make the denominator 0. Okay, that is what the domain is. So when you're finding the domain of a rational expression, what you would do is you would take the denominator. So let's say we had 1 over x minus 4. You would take the denominator, set it equal to 0, and then you would solve for x. Here you would get x equals 4. Well, if I had 4 minus 4 in the denominator, I would get 0. So that actually tells you the restrictions of the denominator. So then there you say that the domain is all real numbers except x equals negative 4. And you write that with this set notation here. So your curly bracket, x, then a line here, and then x is not equal to 4. Okay, so let's take a look at another example. So this is going to be when I look at the denominator, I have an x cubed, which means there's going to be 3 values of x that the denominator cannot be. Okay, so I'm still going to take this denominator and set it equal to 0. So I have x cubed plus 6x squared minus 7x equals 0. So I have to find the values of x, and then those would be my restrictions on the domain. Okay, so here I could pull a GCF of x out of these. So I'm going to do that. X cubed over x is going to give me x squared. 6x squared over x would give me a 6x. And then the x's cancel here for a negative 7. Then I'm going to continue to factor this. It's a monic trinomial. So I'm going to put my parentheses. And I'm going to split the x squared into x and x. And then I'm going to say, okay, what multiplies to 7 but adds to positive 6? And we're going to say 7 and negative 1, yeah. X plus 7, x minus 1. Okay, so I have factored that. Now I want to find those values of x. So I take each factor, set it equal to 0. So I have a factor of x equals 0. I have a factor of x plus 7 equals 0. And x minus 1 equals 0. So in my x plus 7, I'm going to subtract a 7. 0 minus 7 is going to give me negative 7. And then in x plus 1, I'm going to add 1. 0 plus 1 is going to give me 1. Which means that if I plug 0, negative 7, or positive 1 into the denominator, I get 0. So I put the line through the equal sign. So x cannot equal any of these for our domain, which means the domain would be any number except these three numbers. And then we would put it in this A here. Okay, so B, that would just mean that there are no restrictions. Okay, so when you look at this, A and B, so A is x is a real number and it cannot equal 0, -7, or 1. If there were no restrictions, then you would pick B. So no restrictions would mean there's no values of x in the denominator. Okay, so it would just be a normal problem like x over 3. For example, this one. So I have f of x equals 5x minus 4. There's no denominator. The denominator here is 1, which means the domain is this example where x is a real number, okay, because there is no denominator. There's no x values in the denominator, so that is fine. But in this next example, there is an x value in the denominator. You have 3x. So we want to find that restriction. So we take the 3x, we set it equal to 0. Now in this case, we're going to divide by 3, and we're going to get x equals 0, which means x cannot equal 0. So we would choose the first choice, the domain x is a real number, and x is not equal to 0. Okay, now it is important to note those restrictions because we are going to be solving these problems. And sometimes when we solve the problems, we're going to get a value that is a restriction, in which case we would then have to throw it away. All right, so solving equations. So solving equations is just like solving equations with fractions. You want to get rid of the fractions first. Okay, so in order to do that, when we were doing problems where we were getting rid of fractions, so let's say, for example, we had like 1/10 plus 2x over 5 equals 7. If we did that problem, we would have multiplied everything by 10, right? That's what we're doing here. When we multiply just the numerator. We multiply by that not least common denominator, the entire common denominator. Okay, not just what's missing like what we did in section 7. Okay, so it's just like this, except now you're doing it with factors. So it does get a little more complicated. Okay, so we want to follow the steps. So the first thing we want to do is factor any denominators. So I have an x squared minus 16. That is going to factor to what? X plus 4, x minus 4. Good. Can I factor anything else in this problem? That's already factored, so we're just going to leave it. So looks like that's it. Okay, now we want to take the factors, set them equal to 0 so that we can note the restrictions. I'm going to do that over here to the side. I have x plus 4 equals 0. This has a denominator of 1. I don't need to worry about that. I need the x minus 4, and the other one's x minus 4 also. So my restrictions would be, this would give us a -4, and then this one I'd add the 4, so that would be +4. So my restrictions, x cannot be -4 or +4. Okay, and then we want to find the least common denominator. Remember, the common denominator with factors, you just want one of each factor. So in this case, x plus 4, x minus 4. Okay, I don't need to include the 1, and I already wrote the x minus 4 down. So I'm going to rewrite the problem for step 4 so I can have some room. because we are going to be doing a bit of writing for that part. I'm going to leave some room. Okay, now step 4, I multiply each term by the common denominator, just the top. Okay, so each term I'm going to write an x plus 4, x minus 4 to the next to the top of each one. Okay, that's why I needed some room. Then we clear the denominators. So in the 64, the x plus 4s and the x minus 4s cancel. Nothing cancels with the 3. In the last term, the x minus 4 cancels. Okay, so let's bring this down. We bring down a 64 minus 3 times x plus 4, x minus 4 equals 2x times x plus 4. The denominators are cleared, so now this is going back to section 7. I'm just solving a quadratic. So I have to solve it and then check the solution against the restriction. So to solve it, I have to multiply everything out and go from there. So let's go ahead and do that. So what I'm going to do is I'm going to do the x plus 4, x minus 4. If we multiply that whole thing out, remember we factored it before? It was x squared minus 16. So that actually is just x squared minus 16, multiplying that out. Okay, then I'm going to distribute that 3. So I'm going to get 64 minus 3x squared. And then that's going to be plus 3 times 16, 48. And then over here, I have 2x times x is going to be 2x squared. And then 2x times 4 is going to give me 8x. Okay, and I'm probably going to run out of room, so I'm going to move over to the side here. So I want to move everything to one side now since I have some quadratics. So I'm going to subtract the 64. Okay, nothing to subtract it from. I'm going to add the 3x squared over here. And I'm going to subtract the 48. Okay, that way this side, everything cancels. Okay, so if I look here, this is what I have. 2x squared plus 3x squared will give me a 5x squared. 8x will come down. And then I have negative 64 minus 48. That is going to give me negative 112. And then on this side, you have 0. So we have to solve that. So we're still working on it. Okay, we've got everything to one side. We could factor, maybe. Or we could use the quadratic formula. I'm not sure if you could factor this. 5 times 112 is pretty big, so it might be hard to find some factors. So let's go ahead and use the quadratic formula for this to solve. Okay, so we're going to go negative b. So you have negative 8 plus or minus square root of b squared, so 8 squared minus 4. Your a would be 5. Your c, negative 112. All over 2a, so 2 times 5. All right, let's work this through underneath the radical. So 8 squared is going to give me 64. I have 2 negative signs, so that's going to be a plus. 4 times 5 times 112 is going to give me 2240. And 64 plus 2240 is 2304. So that's what's under this radical here. So I've got negative 8 plus or minus 2,304. Oh, sorry, the square root of 2,304 over 10. Now, let's see if that's a perfect square. Ah, it is. So 48. So then this becomes negative 8 plus or minus 48 over 10, which means I can break this into two problems. Negative 8 plus 48 over 10, negative 8 minus 48 over 10. So negative 8 plus 48 is going to give us 40 over 10 will give us 4. Negative 8 minus 48 is negative 56 over 10. And I think I can reduce that just by 2. 56 divided by 2 is going to be 28. 10 divided by 2 is going to be 5. So I get two answers there, or a negative 28 over 5. And then I have to look at my restrictions. What are my restrictions? Negative 4 and 4. So 4 was a restriction, which means this guy has to get thrown out. So my only answer there is negative 28 over 5. All right, that's a long one. Let's do one that's a little shorter. So there's some short ones, some long ones. Again, step by step here. Oh, there's the problem. Rope it off here. Okay, so you have 1 over x minus x over 16 equals 0. So the first step is to factor the denominators. Denominators are just one term, so I don't need to do that. Step 2, I want to note my restrictions. I do have an x in the denominator, so I'm going to have a restriction of 0, because I can't have that x be 0, because that would be 1 divided by 0. So I can't have an answer of 0. Step 3, I want to find my common denominator. What is my common denominator here? I want one of each. So I want an x, I want a 16. So 16x is my common denominator there. Okay, I'm going to rewrite this down here. My common denominator is 16x, so now step 4, I'm going to multiply each term by the common denominator. So multiply by 16x, multiply by 16x, multiply by 16x. In my first term, the x's cancel. 1 times 16 is 16. In my second term, the 16's cancel, and I have x times x, and it's minus x squared. And then 0 times 16x is 0. Okay, so I have negative x squared equals 16. So I could factor this, or I could just go ahead and solve this. I could subtract a 16 from both sides, get negative x squared equals negative 16, divide by negative 1. That will give me a positive x squared equals positive 16, and then take the square root. And when I take the square root, I cannot forget the plus or minus. So that would give me x equals plus or minus 4. And my restriction is just 0 there, so these I can accept. So I get 4 and negative 4 for my solutions for this one. Questions? Okay, I know it seems like a lot, but again, just step by step here. All right, so example 3, step 1, factor the denominators. Okay, so first denominator, I have x squared plus 9x plus 20. So that's monic. So I'll set up my 2 parentheses. What multiplies to 20 and adds to 9? 4 and 5. Yep, so x plus 4, x plus 5 there. 2x plus 8, can I do something with that? Yep, I could divide by 2. That would give me 2x divided by 2x, 8 divided by 2, 4. And then x plus 5 by itself. All right, so let's make this nice and clean here. Leave room because you're going to multiply. Okay, we want to note the restrictions. That's step 2. So each factor would get set equal to 0. So you have x plus 4 equals 0. Okay, that would give us an x value of -4. You have x plus 5 equals 0. That would give you an x value of -5. The 2, there's nothing to do with that. 2 doesn't equal 0. X plus 4 we did, x plus 5 we did. So my restrictions, x cannot equal -4 or -5. All right, step 3, I need to find the LCD. You want one of each factor, so start on the left. X plus 4, x plus 5, 2 is a factor. That's got to come in. X plus 4, already wrote it. X plus 5, already wrote it. So the LCD is 2, x plus 4, x plus 5. Step 4, multiply each term by the LCD. Clear the denominators. So each term you're going to write 2, x plus 4, x plus 5 next to it. And then let's see what we can clear. So in my first term, the x plus 4, x plus 5 clears. I'm going to bring down a 2 times x minus 3. In my second term, the 2's and the x plus 4 is clear. So I'm going to bring down a 2 times x plus 5. In my third term, the x plus 5's cancel. So I'm going to bring down a minus 2 times 5 times x plus 4. And 2 times 5 is 10, so I'm going to make that 10. Denominators are gone, no more fractions. So now we're going to go through and solve. So we're going to want to distribute here. I have 2 times x, 2x. 2 times -3, -6. 2 times x, 2x. 2 times 5, positive 10. Distributing a -10 here, -10 times x, -10x. -10 times positive 4, -40. On my right side, I do need to combine some like terms. So let's see here. 2x minus 10x is going to give me a -8x. 10 minus 40 will give me -30. Okay, I'm just going to move this over here. So I have 2x minus 6 equals negative 8x minus 30. And now I'm going to solve. So I'm going to take that negative 8x and I'm going to add 8x to both sides. That's going to give me 2x plus 8x, 10x minus 6. These cancel. Negative 30. Then I'm going to add 6. That's going to give me 10x equals negative 24. Then I'm going to divide by 10. And I get x equals negative 24 over 10. And those are both divisible by 2. So negative 12 over 5. And my restrictions were negative 4 and negative 5, so that one is okay. All right. We got one more example here. Now, this one, because it's a fraction equaling a fraction, technically you could cross multiply if you wanted. But we're going to do this the same method, same steps to keep it consistent, because you can still do that also. Okay, so we can factor, what can we factor here? Yeah, x squared minus 9 is going to factor to x plus 3, x minus 3. Okay, let's note our restrictions. You have an x minus 3. Set that equal to 0. That means x cannot be positive 3. And you have an x plus 3, which means x could not be negative 3. So your restrictions are 3 and negative 3. All right, I'm going to rewrite this down here. Okay, we need an LCD. What is that going to be here? Very good. X plus 3, x minus 3, just one of each factor. Step 4, we'll multiply each term by the LCD. So each term gets multiplied by x plus 3, x minus 3. Okay, so on the first term, the x minus 3's cancel. Second term, x plus 3 and x minus 3 cancels. So what I bring down is 10 times x plus 3 equals 60. And then we're going to go through and solve that. So 10 times x is 10x. 10 times 3 is 30. We will subtract 30 from both sides. That'll give us 10x equals 60 minus 30, 30. And then divide by 10. I'm going to get x equals 3. But what was the restriction? I don't have anything. Nothing's going to work there, so that is no solution. Okay, so it is possible to get an answer and then have that be extraneous and then have to say it's no solution.